Afternoon, student. Can you hear me? Can you see the screen?
Yes, sir.
Yes, sir. All right. Sorry for the late start. You mean to work today and I have to do some run up and down. I make emergency stuff, but we're here. Happy that I'm still able to have a class today. Because I wanted to work through this paper. Think about it, and I have solutions for this paper, I sent you a couple of weeks ago. Well, last week. But I just felt as if I wanted to work it out myself with you, the question that I gave you, rather than just send you those solutions. That's because this is, like a long time ago, like over 10 years ago. We're going into 2025. And I think maybe, some of the approach, the method that I will be using then for the solution will be different. So I just felt that I should go through this one. All right, so let's do this. So I gave you a couple questions from me. We're not doing all of the questions. All right, just from the topics that we have covered and some topics that we're not going to be doing. Like as topics, topics that we just learn by example, like number one. All right, so we're going to start at number one. Now see if we can clear these questions in about 2 hours or less. All right, so let's go. This first question is a use your calculator question to get the exact value of this and that. And the matter of typing this in the calculator exactly as it is. And that's why I always say it is important to get one of those calculators that you're able to type this in and have it look exactly as it appears there. They call it the textbook display calculator. All right. So that's why I insist on you getting one of those. It don't make sense you have something like that to calculate because you're not able to enter it in the calculator the right way. You get the wrong answer. Right? But this is just almost like a question where you get the mark for just getting the right answer. Like the 2 marks and the 2 marks. I don't want to give away any mark. All right, so let's type this in the calculator exactly as it appears. So it's a fraction. Then we have a mixed number. That mixed number is 1 and 4/5. 1 and 4/5. We're subtracting a fraction of a third.
In the laptop?
Mute the mic, please. A mixed number of 2 and 2. And they want the answer of that fraction, right? So that's not the exact value. So they cannot give that answer. They cannot give the 0.61. The bar up here means that it is a repeating 6-1. That means the 6-1, 6-1, 6-1, and so on, right? That's what the bar on top here means. To see it as a fraction, and your calculator should give it to you as a fraction, and this is it. This is what they're looking for. 11/18. And the matter of just double checking that what you have here is exactly what you typed up there. 1 and 4/5 minus the third divided by 2 and 2/5. Yes, that's the same thing. And so you're writing down this answer as 11/18, okay, using your calculator. And for this one, I want to do the same thing. Just type that in the calculator exactly as it appears there. I'm going to shift this up. This up here. And the rest one out. Put it there. So it's a square root of 1.5625. Come under the square root sign, and then we're adding 0.32 squared. That is it. All right. And so that one, exact value is 1.3524. 1.3524. And that is it. But okay with that? 4 is the mark. That one. But good?
Yes.
Yes, sir.
All right, then we'll come to this question. It says, Smiley orange juice is sold in cartons, 2 different sizes, and the prices are shown in the table. All right, so these are the sizes. So there's a 350 ml for $4.20, and there's a 510 ml and 450 ml for $5.50. And this is what we call a better buy question. All right? Which one is the better buy? Something that you need to practice when you go into the store. It's a different size of the same thing. Which one is the more economic buy? So there are multiple ways of doing this. One way is to see how much you're getting for your dollar. I think maybe that is one of the easiest way to do it, where you want to see how much it is for $1, how much juice you're getting for $1 in each carton, and the one that you're getting more of for $1 is the better buy. All right, so we can basically do it like a ratio, So this amount is for this. I want to see how much it will be for $1. You're going to divide by this 4.20 to get it down to $1. You divide this by the same 4.2 to get it down to $1. So let's put it out here. If we bringing this to $1, we will divide by 4.2 to see how much we're getting for $1. So we have to divide this also by 4.2. And we can put the amount over here, how much it is for the $1. So this will going to become $1. I will need to divide this now by 4.2 as well. And so it will be 350 divided by 4.2, and that's 83.3 mil. So it means that 83.3 mil is the amount for $1. We need to do the same thing for this one as well. We want to know how much we're getting for $1. So to bring this to $1, we need to divide it by 5.13. Divide this number by the same value to get it down to 1. We divide it, it's going to get $1. That's up the second carton. You have to divide this by the same amount. Divide this by the same 5.13. I want to see how much it is and put it over here. So I'm going to divide that amount of 450 divided by 5.13. That's 87 point, let's call it 7 or even 0.7, doesn't matter. So it means that in this second carton, you're getting more juice for $1. And so this one is the better buy. 451 is the better buy. And this is the calculation. It said justify your answer. This will be the calculation. You divide this to get it to $1 and divide this by the same amount to see how much you're getting for $1. There's another way to do it. You could divide this to see how much you're paying for 1 milliliter. And the one that you're paying less money for 1 milliliter will be the better buy. But I think maybe the $1 approach is the better, it's the easy approach. And I've thought it the other way as well. But I think seeing what is how much you're getting for your dollar is is an approach, and it is even a real life phrase that people use. The phrase that real world, how much you're getting for your dollar. So the second one is the better buy. So this one is the better buy. Second carton, 450 ml carton will be the better buy. You're getting more for your dollar, more juice for your dollar. This one will be the better buy. But I'll go do that. I kind of do it rough, but anyway you want to explain it, all right. This will be the better buy. You're getting more for your dollar. All you do, you divide it by the money, guys. Divide it by the money to bring it down to see how much you're getting for $1. Doing it as a ratio, like I divide this by the 4.2 to get it down to $1. But I have to divide this by the 4.2 as well. And then for this one, the second one, divide this by the 5.13 to get it down to $1. So divide this amount by the same 5.13. And you see that you're getting more juice, 87.7 mil for $1. So that has to be the better buy, the one that you're getting more of for your dollar. All right, can I move on? Everybody good with that? But okay?
Yes, sir.
This next question here says, pay borrowers, this is some consumer rate, right? Pay borrowers this amount of money and you're paying 8% per annum compound interest. Now, there's a compound interest formula, but we don't have to get into the formula thing, right? So compound interest works is that you apply the interest to the total that is in the account when the interest is being applied. All right. Simple interest, you would apply the interest only to the original amount, which is called the principal amount. All right. So this one says calculate the loan. I'm going to do it step by step. All right. Just that I don't have a lot of space. So I wanted to keep the calculator on the screen. Where it says calculate the interest for the first year. So 1 year is going to be 8% of this amount is the interest. 8% of the original amount is the interest. There's 8%, which is 8 divided by 100 or 0.08, right? 8%. Some calculator can actually put in 8% like that, as you can see here, right? Some calculator can put in the 8% on the calculator, as you can see here right now. See it right here, right? And see if you notice, it converts the 8% to 0.08 down on the equal line there. All right, so or you could put 8 over 100. We could say 8% times the 9600, right? This is 9600. 9600. I will get that is $768. So that is the interest accrued. That the amount is being added to this principal amount to form the new amount. All right. So the interest amount right here would be $768. That is the interest that asks for. All right. On you on this line. Okay. Interest after 1 year. Calculate the interest on the loan for the first year. Remember now, the second year interest is also going to be calculated on this amount. So you're going to add these two amounts now to start the second. That would now be the start of the second year. Right, the total, we're going to add them. I'm going to apply the interest now to the total. All right, that's how compound works. It says at the end of the first year, she repaid this. All right, so let's look at it now. So it means that the amount owing is going to be reduced by this. All right, so let's look at it. It says, how much did she still owe at the beginning of the second? So she amount owing at the beginning of the second year is the amount that she started with plus the interest minus this amount. Right? Subtract what the amount that was repaid. That's the amount owing at the beginning of the second year. All right. So the answer for this one, part 2, let me just do it right here, is the principal amount, which is 9696, all right, 9600 plus the interest of 768. But then she repaid this amount at the beginning of the second year. Right? Or at the end of the first year. The end of the first year, the beginning of the second year is the same time, really. Right? In accounting terms, the end of a period and the beginning of a period is the same time, the same instant. Really. All right? So subtracting the amount that was repaid, which is 4368. All right, so let's do a calculation. So it's 9600 plus the interest of 768. And subtracting at 4368. So the amount owing still after she made that repayment is now $6,000. So this is the amount at the start of the second year, $6,000. But good at that? But okay with that?
Yes, sir.
Then it says now calculate the interest on the remaining balance at the second year. So the interest is now going to be calculated on this amount. They're taking 8% of that amount of the interest and the remaining balance. And this is the remaining balance. All right, so I'm going to charge the interest on that. So part 3 is now going to be 8% times that 6,000. Very easy question. So we're going to charge 8% times 6,000. Because the interest I want, right? So they don't want the amount in there. There's no going to grow by that amount outstanding. That is it. So this is the answer for the next part, $450. Right. End of question. Yeah. Very good. All right.
Yes, sir.
Yes, sir.
All right, let's jump down to number 2. And I think I don't need the calculator for number 2. So let me get this off the screen now and I work on it. Number 2. All right, bang, bang, bang. First part wants us to factorize this completely. All right, let's go. So we have 2x cubed minus 8x. Initially, all we have is a common factor factorization. Whenever I say a minus between the terms here, my mind is thinking about the difference of 2 squares. You have to look out for it. But initially, it's just a common factor of 2x. In terms of the numbers, the common factor is 2. In terms of that variable, common factor is x. So it's a 2x common factor. Out of this, we're going to be left with x squared. Out of this, we're going to be left with a 4. If you recognize inside here, you have the difference of 2 squares. You cannot stop there. As the question said, completely. This is the first line of factorization. This part can be factorized as the difference of 2 squares because it can be written as the difference of 2 squares. So it's going to become 2x as the first factor. Don't throw it away. Inside here, I'm going to write it as x squared minus 2 squared. Then the rule for the difference of 2 squares inside here will become the difference of the 2 values times the sum of the 2 values. It becomes 2x, which is the first factor. Then the factors of this now can be written like this. Is x minus 2, x plus 2. And so I factorize that expression completely. But go to that. But okay?
Yes, sir.
All right. We'll come to this one. Factorize. That's a quadrant. Right? And I don't like to do mathematics. No. Sure. What it's called squared minus factorizing one line, guys. For the simple reason that this first term is like a prime number. All the factors of that number is 3x and x. This also is a prime number. All the factors of that is 1 and 2. These are the values that will go inside the bracket. It's just a matter of where you put them. All right. So when the n values are prime like that, we don't need to go through that lengthy process of splitting the middle term and all of that. All right. It's kind of quick and fast. We can do it. And we have to learn to do math easy. All right. Practice. So all the factors of this is 2x, 3x, and x. All the factors of this is 1 and 2. There's either 1 and 2 like that, or 1 and 2 like that. Remember, what happens is that the far product and the near product must be the middle term. I have to be careful. All right? Let me give you a thing. Now, this negative tells me that it is the difference between the far product and the near product that must give me the middle term. The difference. If this value was a plus, if this value, this sign was a plus, then I would need the sum of the far product and near product given the middle term. Because it is a minus, I know that I need the difference. The difference must give me the middle term. So if I put the 2 here and the 1 here, far product is going to be 6x and the near product is going to be 1x. The difference between 6x and 1x is 5. So I already know that those values are in the right place. They're in the right place. Well, let's say I put them the wrong way. Put 2 here and the 1 here. My far product will be 3x and my near product will be 2x. The difference between them is 1x. The difference. No, this tell me that I need the difference. The difference between 2x and 1x. Mentioning I have now these. So correct way to have them. Difference between the far product and near product will be 5. All right. Let's take it a little bit and expand it another step further. When the last value again is meaning that the 2 sides, that is done by the first. Something is on the first term, the square term is position. All right, guys. Sorry about that. Back with me. Can you see the screen again?
No, sir. It's
No,
clear.
sir. No, sir.
I need to share. Okay. Share. Internet a little bit unstable now here. I'm somewhere different today, so let me use the hotspot. All right, so let me continue. I think the recording would have captured everything that I've said. So, I'm not just sure. Okay, I know you all know the process, and I'm just showing you the shortcut way to do it, right? Let me just repeat this part of it. I'm saying this tells me that it's different two signs. Two different signs must be in the bracket. One positive and one negative. For the larger of the far product and the near product must have the same sign as the middle term. All right? And the larger product is the far one. I have to make it negative like the middle term. It means that I have to put the negative here and the plus here. And this kind of that is no, everything that I just did can be done like within seconds. Even though I spent some time explaining it, it can be done. To go from this to this is like in seconds. You can factorize to that when the n values are prime and when you just know those little tips, the things that I showed you. The one day I write them out for you so you can study them. You know, and once you factorize, you can always double check to see if it is correct. Because this times this, those two give you a first term. The product of the second values give you a third term, which is correct. Remember now that the middle term is the sum of the far product and the near product. That negative 6x is the far product and positive 1x is your near product. Right? And so those add to the middle term. Minus 5, minus 6 plus 1 is negative 5. All right, so if you see, like I spent a lot of time on it, you know, this can be done like within seconds. All right, factorize. We need to practice it, especially when the n values are prime like these. All right, let's move on. But good, but good.
Yeah.
Okay,
Yeah.
let's go. This question wants us to see the subject of this thing. All right, like transposition. I tell people all the time, when you can transpose and simplify expressions, 3/4 of the problems in maths are solved. And just being able to transpose rearranging expression. Something that you have to practice and make sure you get good at. All right. All right. 32. I want to make this a subject. I like to transpose away from it. That's what that's away from it. Transpose everything away. And nothing is that when you transpose, sometimes like reverse. Now, which I'm going to move this to first while you're on subtractive. I'm looking away from C. I want to make it the subject. Because minus 32 equals 9 over 5 C. Then this 5, I'm going to take it and multiply it up here. I'm going to multiply the entire side by the 5. Same as Go on again, guys. Go on again. Internet unstable. Pull on at button. Yeah, as I was saying, no, I'm gonna move this 5. I'm gonna multiply this 5 across here. Yeah, they must say multiply both sides by 5. So number from 5 bracket f minus 32 equals 9. And take this 9 and divide it on the here. Leave it here as the subject. So it become 5 into f minus 32 all over 9 equals C. That's not the only answer. Right? I can write it now 519 times f minus 32. That's not the only way to express it, but that's the all right. Very good.
Yes, sir.
Okay with that.
Yes, sir.
And given that f is 113, what is the value of C? So this guy going to be using this form of this formula. So when the f is 113, from 113 put it right here, C is going to become 519 bracket 113 minus the top now. Right, so the first 519 113 minus the I'm not going to get this sample. 45. 45. 45. This is the conversion between degrees and Fahrenheit, by the way. Right? It is a Fahrenheit equal degrees Celsius and Fahrenheit. All right, but good. Make sure good as well.
Yes, sir.
Yes, sir.
But we are getting everything right. This one says 500 is a solar concept. 500 is total number of solar concept. These tickets, X of them are sold for $6 each, and the remainder are sold for $10. 500 total. 500 total. And it said X at $. And so the remainder will be 500 minus X. 500 minus X at $10. See? So they said, right? 500 tickets total. X of them are sold for $6. The remainder will be going to be 500 minus X sold for $10. That's what the difference is. It says now, write an expression in terms of X for the number of tickets sold for $10. The 500 minus X, the number of tickets sold for $10. That's what I have here. But okay with that?
Yes, sir.
Yes,
Okay
sir.
with that? Total amount of money collected for the sale of the 500 tickets. So this plus that. Total amount. Total amount has to be $6 times this, $6 times X plus 500 minus X times $10. $10 times 500 minus X. $10 times 500 and this can be simplified. So let's simplify. Always simplify when you can. So this is $6 plus from $5,000 minus 10x 10 times 10x and then from this 5,000 and then 6 minus 10 is negative 4. That's negative $4. That's the total amount. That's an expression. Right? Total amount. All right. Then it says no, the sum of $4,108 was collected for the 500 means that this amount is equal to the 414108. That's the most total amount collected. And we want to calculate costs, calculate the number of tickets per X. This going to ask the most for X. Number of tickets per X. All we have to do is equate this amount to the total collected. So it's 5,000. You can drop off the dollar sign now. Minus 4 to the equal 410. Trying to find it. Right? Put that first over here. 4 equals 5,000. And so I have subtracted 410. You take this one divided on here. And tell you now 1 here. That gives you 5,000 minus 410 is divided by 4. Fraction 5,000 minus 410 all divided by 4. 223 equals 223 to the number. So you tell us that so 223 so all right. Very good.
Yes, sir.
So we get 24 marks so far now. 12 and 23. 11 and 11. We get everything right so far. Oh, just giving one number 3. I gave it to this one to the right, 3D. I'm gonna give it 3D. That's 3D. 3. It says in the diagram below, not drawn the scale. AEC and ADB are straight line. That's a straight line. Straight, right? It says angle 9, angle 9. So we have two right angle triangle. So we have small right angle triangle here. We have a large right angle. These two triangles are in fact similar triangles. Similar. It says that one is 10, one is 8. So this is a 6, 8, 10 triangle. This side is 6 and 6 triangle big one. Right? And then this side is 3.2. It says calculate the length of BC. And if you know that is 6, we're doing it, safe. So you're working in this big triangle now. Find the BC, the right angle triangle. And once you know two sides, Pythagoras theorem will give a third side. So you should know that answer is 6. The third side here is going to become the square root 10 squared minus 8 squared, which is going to work out to this. Let us do. Are you good at that? That is.
Yes, sir.
Explain why these two triangles are similar. Topic that we have not yet done, because they are similar. That this one, I told you, big one, this small one, are similar, but they have 3 equal angles. Let me show you. So this angle is the same for the small triangle and the big triangle at first angle. And this angle is 90 and this angle is 90. So they have 2 angles same, and then this angle here and this angle here is same. Because they have 3 equal angles. 3 equal angles. They are similar triangles. The 2 triangles, they have 3 equal angles. That's the reason. Each of them have same 3 equal angles. Right? They are similar, but they have 3 equal. The one and that's one of this one. That's the 3 equal angles. They have the same angle. 3 angles is the same in both triangles. three angles is the same in two triangles. They have the same three. Three angles. Right, they have the same three angles. All right. Next one down here says calculate the PE. PE is this side. And you know, what happens in similar triangles? The ratio of corresponding sides are equal. Ratio of corresponding sides are equal. So for example, the ratio of these two sides, this one to this, is equal. We need, for example, this small one to this large. So we need to know. All right, so we need to know this side. This side is going to be 8 minus 3.2, right? That side is 8 minus 3.2. So the 8 minus 3 is 5, is 4.2. This side inside here says 4.2. 4.2. All right, let me show you what we can do. On the small triangle, I'm going to draw out in blue. We have this larger triangle, so I'm going to draw out in red. The ratio of corresponding sides are equal. All right, that's the corresponding sides. So this 8 and this 4.2 are corresponding sides. And this side O. Let's call this one X. We can call this one in the blue triangle. Let's write this on the red, on the big one, in the red. The ratio of corresponding side. Let's write this side in red as well. In this long side. What it is that this 6 over this 8, let's call it the vertical over the horizontal, and the big triangle is equal to the vertical over the horizontal and the small triangle. That's how it works. Right? The ratio of corresponding side equal. Anyway you want to position the ratio. If you want to do the small height over the small base, it will be equal to the large height over the large base. You can set up that way. The small triangle, the height over the base, and the small triangle equals the height over the base and the large triangle. So we can say x over 4.2 is equal to, I draw for the red, is 6 over 8. The ratio of corresponding sides is the height on the small triangle over the base on the small triangle is equal to the height on the large triangle over the base on the large triangle. The ratio of corresponding sides are equal. So to find x now, all I need to do is get this 4.8 and multiply it here. So the x becomes equal to, let's use the color code of it, the 6 over the 8 times 4.8. That's going to give us the x. No longer so it's 6 over 8 times 4.8 over 2. This 3. What are good at
Yes, sir.
Yeah.
that? Remember that key thing about similar triangles. You have the same three angles. Okay? Three angles in one, and three angles in the small one, and the three angles in the large one, the same. And then for calculation purposes, the ratio of corresponding sides equal the ratio of corresponding sides equal. Key thing for the purpose of calculation this part, the ratio of corresponding sides. Alright, so that finishes that number. I would not have given you this one, but this one had to do some measurement, right? We have to measure, so couldn't give you this one. I would have to give you the actual weight. I give you this to the part B. This one jump. Right? But this one is straight here. So give us these 2 points. A is minus 1, 4, and B is equal. And there's there are endpoints of a line segment, gradient. The gradient is rise over run. The difference in the y values or the difference in the x values, right? Let's just call the gradient M. M8. Let's say we're doing the B point minus the A point. Let's do the B point minus the A. So the difference in the y values, this y value minus this y value, is 2 minus 4, 4, this x value minus this x value. It's 3 minus this x value is negative 1. There's 3 minus a negative 1. This one here becomes a plus. It's minus plus. Minus plus. So this one works out to be negative 2 divided by this 3 plus 1 is 4. The final result is that it reduces to negative half. The limit of AB is negative half. Then it wants the midpoint of AB. Remember, the midpoint like an average point. Right? So the midpoint of AB is like a midpoint. It's a capital M. The average of these two x values, the average them, remember the midpoint like an average point. Negative 1 plus 3 over 2, the average y value 4 and 2 over 2. So the midpoint, capital M for midpoint, 3 minus 1 is 2, 2 divided by 2 is 1, 4 plus 2 is 6, divided by this 2 is 3. The midpoint is 1, 3. Finishes that point, 1, 3. This part wants the equation of the perpendicular bisector. The perpendicular bisector is the line that passes through the midpoint and the perpendicular. Let me sketch it out for you so you can see it. Minus 1, 4 would maybe be like here, and 4, 2 would maybe like here. So this might be where E is, right? Then now, the line segment from them might be that B. And perpendicular bisector would have passed through the midpoint between this here and it would run perpendicular to them. This question is asking us for this red line passing through the midpoint bisect, puts it in half, it passes through the point M, 1, 3, and it's perpendicular. It crosses that right angle. We're trying to find the red line, square root in line, that's a straight line, that's my device. Remember, to find the equation of this line, we need to know 2 things about it. We need a gradient and a point. I have point already. Perpendicular bisector have one already. Alright, so the point that we have already is point M, is 1, 2. What we need next is the gradient. Let's just call this line 2 for perpendicular bisector. Because it is perpendicular to the blue line, which is the original line, we have what we call negative reciprocal gradient. So the gradient of the line that we want, line 2, come on M for gradient. Gradient of line 2 is minus 1 over the gradient of AB. Remember, gradient of AB is negative a half. So the quick way to do this calculation, right? Gradient of AB is negative a half. Gradient of AB is negative half. So to do this calculation on this gradient, like you would take the negative half and it's gonna here where the gradient of AB is. or the shortcut calculation to do this is to actually flip that and change the sign. Flip it and change the sign. So to flip it first, it's going to become over 3 minus over 1, sorry, minus over 1. Then change it from a minus to a plus. And so it becomes a positive 2 over 1. Positive 2 over 1 is 2. If we flip this and change the sign, it's going to become a 2. So we're going to have this line. We're using this point and this gradient to get this equation. So that equation of line 2 is y minus the y value at the midpoint equals the gradient of line 2 x minus value at the midpoint. This is what we call the gradient point form for the equation of the line, because it uses gradient and the coordinates of a known point, where that known point is the node. So it is y minus the y value at the midpoint is 3. Y minus 3 equals gradient is 2 into x minus the x value at the midpoint is 1. Y minus 3 then becomes 2 times is 2x, 2 times negative 1 is negative 2. Take this 3 and transpose to y, you're going to become positive 3. Remember, y equals 2. It's going to become 3 minus 2. 3 minus 2 is a plus 1. This is the equation of that red. All right, that
Yes,
good.
sir. Yes, sir.
Let's move on. Did I give you this one? Yes. Let's go. Question says, the incomplete table shows one pair of values, A and R, where R varies direct. A varies. A is directly proportional to the square of R. Square of R. Because it's directly is A times. So A equals A times R squared. It's a relation to the two. All right. So see here, it says express A in terms of R and this is part 1. A first variable constant and square constant. If what says you're calculating of K, now you must have seen to a number of questions, variations questions, and not asking this one though. I told you, some will ask you for the K, some will not. This one that is asking for the K. You always use a known pair of values to find K. Known pair to find K. Right? So when it's important to use those known pair of values, that known pair of values to find K. So note that the A is equal to 36 and the R is equal to 3. Plug these values inside there and it therefore means that 36 to the A value is equal to A times 3 squared, R value squared. So this is 9. But divide the 9 and here to get A. A equals 36 over 9. It is a 4. A is equal to 4. Divide here, A is equal to 4. Next part, we said we have to complete the table. So we need to find the value here and the value of there. Complete the table. Right? The value of this and the value. Right. So we're using this formula. You know that when we want to use it for use the formula. Take the 4 and put it in the formula right here. So then formula really becomes A is equal to 4 times R squared. This is the formula now that we're going forward. All right. So for simplicity, let's call this the value of small a. Let's call it the value of small r. All right. So do that. So when you use this formula now, in the pair. On the first pair, the, 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 the A small a, then the R 25 is 5. So R is 0. So the A is small a, and R is 5. Right? Put them in the formula to find the value of A. Put them in the formula. It means that small a is equal to 4 times 5. R is 5. And 5 squared. This 5 squared is 25. 25 times so it's 100. The A becomes 100. Put in 100 in the box right here. Then this R now, we're gonna put 28. Well, it's 196. So, using the same formula here now, just to say the A equals 196 and the R is small r. Again, I plug in those values in this formula. It means that the 196 is going to be equal to 4 times R squared. R. Then divided by this 4, the R squared equals 196 over 4. Do that. 196 over 4 is 49. 49 R squared. You're going to square root to get the R by itself. Going to square root. The R be equal to, remember, it can be plus or minus the square root of 49, which means that the R will be plus or minus 7. But usually, as is the variation system, you want to, decide whether the plus or the minus is valid. In this case, the minus would not be valid because remember, it's an inverse variable. And what does that mean? That these values are increasing. The direct variation, while these values are also increasing. So it cannot be that you have increased from 5 to -7 to increase 5. But it has to be so the R is just equal positive times. Right? So this value is 7 to positive 100. Gotta go to that.
Yes, sir.
Yes,
Yeah.
sir.
I'm not using -7 because remember that direct variation. These values are increasing. These values are also going to be direct variation. All right, let's continue. The f of g down here said the functions question gives us the this. Yeah, yes. First part one, f of g of 2. Now remember, f of g of 2 means we can do the g of 2 first. So then the two inside there. When we right here now, it's going to become f of g of 2 now. Then doing that, so it's going to become 4 times 2 plus 5. G of 2 inside here. And 4 times 2 is 8. And 5 is 13. So it is really f of 13. 13, I'm putting 13. So from equal to 2 times 30 plus 1 divided by 3. This is 26 plus 1 is 27. 27 divided by 3 is 9. It's all so Alright. So this one want f to the minus 3. Alright, the minus 3. Let me just do this way. I'm gonna say let f to the minus 3 be equal to n. After working out f to the minus 1 of x, let's do this. we have to calculate some inverse. So if f the minus 1 of 3 is equal to n, that 3 is equal to f of n. When you calculate n, you found the answer. F of n is going to put n there. So that means that 3 equal to 2n plus 1 over 3. You have to do the inverse. You have to know make this a subject. Find the n. When you find the n, you find the minus 3. Alright? So we're going to take this 3, multiply it across here, and get 9 equals 2n plus 1. We're going to subtract this 1 and divide this 4. Divide this 2, sorry. I'm going to get 9 minus 1 divided under the 2 to n. So the n equals 4. Which therefore means that f to the minus 3 equals 4. We could do the way we find the inverse function first. Still have a transpose to make whatever in this position. So, right? Yeah, like this. That's one way to do it. Nice and easy. We don't actually put the inverse function. And you put in the 3 in there and get 4. That's not the way to say it. All right?
Yes, sir.
Next one, I would have skipped this one. But for that one, it would have given you part B to do. All right? We're going to do a rate change. We're going to do this. We're not there. We're not giving you this part B to do this transformation. All right, it says the graph below shows showing the LMN and the unit L prime and N prime are undergoing a similar transformation. Just from this one, we wanted that. Right? We look at the new transformation without doing anything. To look about transformation in other or say we can know the answer without doing it. Without even reading it. It's like a reflection. To check if it's a reflection, you can check the orientation. For example, LMN on this one this way, LMN. But LMN on this one this way. The orientation is reversed. Orientation is reversed when you reflect in a line. And the mirror line is halfway between the corresponding point. Halfway between these 2 points. For example, the line here, halfway between these 2 points. That is the mirror line. So reflection in this line which passes through 7 and vertical is x equals 7. The reflection in the line is equals 7. That's what that transformation is. Yeah? Describe fully the transformation of the map system. Reflection in the line equals 7. Right? So we can write reflection in line x equals 7. The vertical line can be given x equals a number. The y-axis equals 0. Vertical line that is it. Equal says an answer she provided through a double prime triangle now. Image of the original element triangle after translation 0, -3. So this 0 means that there's no movement horizontal, no movement horizontal. Right? This 3 means 3 units down. So this is a 3 units down only translation. It's 3 units down only. We're going to move the original triangle 3 units down this one. Now our translation, you usually can just move 1 point and then draw about the same shape around that one. So let's say I take the point N up here and I move it 3 units down and check to see if the scale, every centimeter that you want to be. You're moving it 3 units down. So the point N. 1, 2, 3. That will come to here. This is where N double prime and they basically draw about the same shape around that point. Like two below this, you have this horizontal line. Two below this, you have this horizontal line. Right. M double prime, L double. Yeah. One, two, three. That one, one, two. That's it. That's an easy. That's your double prime. Right. Okay. That's what next one says no. Name and describe combination of two transformations which may be used to do the double prime and the two transformations. Right? But we'll take out this one, double prime back to the prime. This to this. A glide reflection have a translation 3 units up followed by reflection in 9 is equal to 4. It's a glide reflection. Translation 3 units up, reflection in 9 is equal to 4. It doesn't matter which one comes first. I could do the reflection first, then translation. A combination, a glide reflection. Note translation, direction, parallel to the mirror. That's why it's a glide reflection. Right? So I'm going to say glide reflection, glide reflection, glide rising of a translation. It's going to be 0, 3. They're going 3 units up. 0, 3. The first one. And second one is a reflection. In the line. So it doesn't matter which one of these come. Which one of these come first. Right? No one can be done first. Those are the two translations. One translation and a reflection in the line. Take it from this channel that to the 3 units of 4. Or can be translated that is 0, positive 3. What I got at that?
Yes, sir.
Okay. Well, that's number 7. Not doing statistics until after plane solid geometry. This one will be the pattern scan for the exam in March. And we'll have given you this one. Well, in the program, you have done already. I would have given you this one to do number 9. All right. This fish wishes to buy X oranges and Y mangoes, but you don't know X and you don't know Y, which he intends to carry in her bag. He says she has space for only 6 fruits. Fruits. The word fruit seems to mean the sum of the oranges and the mango. She only has space for 6. It means that the total of the oranges and the mangoes can be 6 or less. It says write an inequality to represent this information. The number of oranges plus the number of mangoes has to be less than. It says to get a good bargain, she must buy at least 2 mangoes. The number of mangoes is Y. Must be at least 2. These means 2 or more. Equal to second inequality. Next what says, oh, that's right. Next part says more information about the number of oranges and mangoes associated with the good bargain are represented by this. Like that. I want us to write information representing this inequality in a sentence in your own words. You cannot just say y must be less than or equal to 2. In relation to the number of oranges and the number of mangoes. To say in your statement. So y, remember, is the number of mangoes must be less than or equal to. This is twice the number of oranges. So the number of mangoes, which is y. The number of mangoes. The number, which is any number. Number of mangoes. You cannot just say mango. The number of mangoes. Y is the number of mangoes, not mangoes. The number of mangoes must be less than or equal to twice the number of, I run out of space, small and zoom, number of oranges. Everything will mean the same thing. The number of mangoes, the wine, whatever it must be less than or equal. I can say must be no more. Also, they could have said must be no more. It can be no more than twice the number of oranges. You can read and say less than or equal. Instead of saying less than or equal, they could have said must be no more. Can't be more. Equal to twice or less. The number of mangoes must be no more than twice the number of oranges. So the number of mangoes must be less than or equal to twice the number of oranges. That's it. Very good. You okay with that?
Yes.
Yes, sir.
And somebody mic is open. It says on the answer she provided, draw the lines associated with the two inequal. I think they gave one in this. But after the three, and let me give this one. When they gave the actual paper here, they gave the graph, they drew this one. Right? I'm just gonna sketch this, right? They would have also done this sketch. Let me sketch it. So, yeah, please. Mute the mic,
Yes,
please.
sir. Yes, mommy.
Mute the mic, please. Mute the mic. Let's go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Something more than this and y to x. 1, 2, 3, 4. 1, 2, 3, 4. All right. So remember this one, when the y on the left side of the inequality is positive, less than means below. All the lines are going to be drawn solid, but equal is a part of the inequality. Equal is a part of the line associated with this inequality is the line x plus y equals 6. Because of the less than, we're going below the line. When you draw a line x plus y equals 6 with the line crosses the y axis at 6, crosses the x axis at 6. You want to do the line for the x plus y line. The straight line crossing through those two components. You go like that. This is x plus y equals 6. Notice I will label the line with the equal sign, the line with the equal mark. And put the arrow on the here to remind me that I want to go below the line. So the region that I want is somewhere in here between below those lines. below that line. Then the next one is the line y equals 2. The line associated with this one is y equals 2. Greater than means above. The line associated with this one is y equals 2. And we want to go above that line. It's above the line y equals 2. Y equals 2 is a horizontal line passing through 2. 2 here and the horizontal line. Label the line with the equal sign. Y equals 2, put the arrow pointing up, but I want to go above the line. The region I want is somewhere near right now. Below this one and above this one. And the third line is this one. Well, one associated with that. So the line associated with this inequality is the line y equals 2x. And we're going below that line for the left side. Y on the left side is positive, the left hand is below. We're going below this line again. Again, the line is drawn solid because of equal and the inequality. That the line is a part of the inequality. The line y equals 2 is the line that passes through 0, 0. And passes through a point where the y value is 2 times the x value. For example, if the x value is say 5, then 3, and the y value is 6, plus 2 times 3 is 6. So it passes through those 2 points. It passes through 0, 0 right here. It passes through 3, 6. 3, 6. 3, 6. It also passes through 4. The line there, so the line. Label the line with the equals sign at y equals 2x. And we want to go below this line as well. The region I want is above this line, below this one, and below this one. We're talking about this triangle. The shape not that's what it's shape. Shape. Most of the shape, let's say shape, but not every time. All right. So draw the line to shape on your graph, you can satisfy. That's it. All I wanted to do. This question didn't require us to go to the vertices and anything like that. That is just to draw the line and shade it. If you want the maximum or minimum of anything, you have to go to the vertices. But this one didn't want it. This vertex would have been 2, 4. Vertex would have been 4, 2. This vertex would have been 1. You want to work out maximum of anything, so you use these two vertices for maximum distance. So it's going to be maximum of anything. You want the minimum of anything, you go to that. That's the value that will. All right, that finishes that one, and then we come to 5B, which is what I would have been to do as well, but I will complete in the square. Out of this. All right, so we have this positive expression. We want to write it in this form, with the vertex form. Write it in that form by completing the square. And do from this to this. The method that we use in this class, we don't use the H and K. We use T and Y. T meaning turning point. Right? So let's call it Y. Let's call it expression Y right here. Let us call it Y in the beginning. I want to say Y equals x squared minus 12x plus 8. When we complete the square, it's going to become Y equals A into x minus 2 squared plus YT. So even though they have a plus here and there, we use minus here and over. When we calculate the x value there, the x value at the turning point and the positive function, it's going to be the y value at the turning point. This one is going to be a minimum turning point because of the square term is positive. The square term is positive, we have kind of a smile shape. Because a smile shape for a minimum turning. How do we calculate this? Same as before, using a formula method. Other way to do we're using a formula. I don't know. The A that we use in the formula, coefficient of the x squared is 3. It's 3 parabolic. Then now the next part is b negative 3, and then the c is 2. That 2. All right. The formula for the xt, let's go back for the blue. Is minus e divided by 2a becomes minus, and then the b is negative 3 divided by 2 times a. A is 3 as well. So make sure. Oh, sorry, the b is negative 12. And that makes it negative 12. Negative 12. This becomes a positive 12 over 6 times 3, which works out to 2. And when my xt is a whole number as it is now, I can find my yt by taking the xt value and plug it in the original function. And in the y value here equals 2. Y value. Don't have to use a formula way to do it. I'm going to use that method to understand. Yt is 3 times 2 squared minus 12 times 2 plus 8. This is 4 times 3 is 12, and this is 24 plus 8 is negative 12 plus 8 is negative 4. So my y is negative 4. Now that I know the x and the y, I can plug them back into the expression. This thing, y is equal to the a value. Remember, the a value is 3. X minus the value right here is 2. Don't forget the square. Plus yt is negative 4. On the right, negative 4. So yt and that will compute the square. I'll go do that. Okay.
Yes, sir.
Yes, sir.
But once I sketch it, to the just get a function. We have to show the y-axis intercept, which get from that constant value c there. So y-axis is 0, 8, and the minimum point is yt, which in this case 2, 4. So just get a smile, greater positive, so on. This y-axis is to scale with that smile. No, turn has to be somewhere down with x value is positive and y value is negative. Positive x value, negative y value, put it down here, so turn it down. And then this value, this y axis negative, has to be somewhere on the positive part of the y axis. It turns down here and crosses somewhere here. That's how I have to draw a smile. Turns down here, crosses up here. The y value. Right. We let that to scale. I'm going to put my 0, 8 intercept. And minimum point, I'm going to put it here, 4. That's all I want. Sketch of I equals j squared minus 12 maximum point. So wanted the axis of symmetry with a vertical line here, which we that. So that finishes that question, guys. We have got it right. Very good. We have one more to do.
Yes, sir.
Yes, have a question? You have a question? No?
No, sir. No, sir.
Even this one, we're going to be used, right? We're going to have to do it right after the new year. Finish these, then we're going to do this stuff. Right? So start in class with again, we'll be including number 9. So here now we're at vectors. Let's go. All right, this question gives us diagram on scale. There's P and Q are midpoint OA and OP. This is the midpoint of this side. This is the midpoint of that. And it says OA is 2A. They did not show that. So this vector is 2A. So that vector is 2A down here. And this is the midpoint. Then I can divide that 2A as A right here. This has A. And other A from P to A. P to A. Other A. A. 2A. And then the vector here we say 2B. Let's put that there. Here is the vector 2B. All right. And question says expressed in terms of a small a and a small b, the vector AB. So the vector AB, since you have two position vectors, this can be and the last one and the first. If we look at the diagram, so how do I go from A to B? I go 2A back this way, that's a negative 2A, and then plus 2B, plus 2B. That's under from A to B. Or you and the last one, in this case, OE and OA. B is the last, A is the OB minus OA. The OB is 2B minus OA is 2A. That is. Then I want the vector PQ from here to here. So looking at the diagram, from P to Q, start out. Now come over to here first with the A, and then go here, A to Q using a half of the A. That is to take from P to Q. This and that. Nice and neat. Right? So let's do that. So from equal to this A here plus half of AB. Now, half of AB is half of this. I can write it here. Half of AB becomes B. Half of AB minus B. Half of this is B. Half of this minus B. B minus B. I'm adding this now here for this part. And I'm write B minus this A and this minus B cancel. I'm just left with B. Q right here is a vector B. Vector right here, I'm going to write out in first. If you parallel to that one, so one is a more to the next. This one is just twice as long as that. All right? Here, there's state two geometry relationship between OB and PQ. One, they are parallel because one is a more to the next. And OB is twice the length of PQ. In P, calculation and neutral. Obviously parallel because one is a more to the next. One is B and one is 2B. They could say that OB is 2 times PP. So that makes them parallel. So one, they are parallel. OB is parallel to PP. Twice as long. OB is twice the length. So it's done. We now have a relationship between two lines, give them parallelism, give them the relationship of the length. Right? Very good.
Yes, sir.
Yes, sir.
Gives us this matrix and it wants the inverse. Remember now that inverse is one over the determinant multiplied by that. Right. M is a matrix 2, 1, 4, 3. Inverse part 1 is 1 over the determinant multiplied by the adjoint. 1 over the determinant is this product, first diagonal product minus second diagonal. There's 2 times 3 is 6 minus 4 times 1. 4 times 1 is 4. The determinant under here is just 3. Multiply that by the adjoint. The adjoint is formed by interchanging the elements on the first diagonal, even diagonal. Change. They put the 3 up here and the 2 down here. They leave the elements on the second diagonal where they are. Change the sign. This 1 is where 2 becomes a negative 1. This 4 is where 2 becomes a negative 4. So the final inverse matrix is down by dividing each of these values by this 2. 3 divided by 2. 3 over 2 or 1.5. Negative 1 divided by 2 is negative 0.5. Negative 1. The negative 4 divided by 2 is negative 2. And then 2 divided by 2 is 1. So this is the inverse matrix. Right? Next part says show that m to the minus 1 times m equals I. So you have to know that this I is identity of multiplication 1001. Basically, you need to multiply these two matrices and put them times 1. So number 1, you multiply this one. Right? 1.5, 0.5, 1. New line sendable is 11, 2, 1, 4, 2. You multiply them. You already know what answer. Multiply the rows of the first matrix, the 2 rows, and column the second row. And you are going to get 2 by these 4 values. 1, 0, 1, 0, 1, 0. All right. So to get this value now, position in the first row, first column. Multiply this first row by the first column. Multiply a row by a column. Multiply the first element in the row, first element in the column. Then you multiply the second element in the row by the second element in the column. And you add the percent. So we see first element times first element, an element times second element. First element times first element, second element times second element. Second element. So 1.5 times 2, 1.5 times 2 is 3. Negative 0.5 times 4, that's negative a half times 4 from the negative 2. And the value over here, position in the first row, second column. To get it, multiply this first row by the second column. This first element times first element, an element times an element. There's 1.5 times 1 and negative 0.5 times 3 in common 0. Right? So it's not going to be 1.5 times 1 is 1.5, and then negative 0.5 times 3 is negative 1.5. Then the value down here is positioned in the second row and the first row. So to get multiply this second row by this first column, same way again. First element times first element, element times second element, first element times first element, element times second element. With negative 2 times 2 is negative 4, then 1 times 4 is positive 4. That comes up here. So the last value down here, position in the second row and second column. To get it, multiply this second row by this second column. And we say first element times first element, element times second element. First element times first element, second element times second element. And 2 times 1 is negative 2, and 1 times 3 is a positive 3. Final result, we know that we're supposed to get this works out to be a 1. This works out to be a 0. This works out to be a 0. This works out to be a 1. That is, I think, the fourth row into the minus 1. So this question is not a testing your knowledge, you know that I am. Right? So now, next question says, use a matrix method to find these values. All right, so remember the same thing again. I want to find this, let's say the inverse of this. Do we have the inverse of this? Yes. Right? So based on this, inverse of this matrix must come. If the matrix that we transpose is on front, the inverse goes on front. All right, so basically then, the R is U matrix going to be equal to the inverse of this we calculated already. This is really a M. M to the minus 1 calculated it already. So this one can use that, or can use the one with fractional side R. Like this. So the M to the minus 1 could have written as 1 over 2 times 3 minus 1 minus 4. This is a lot inverse. You don't want to go with those. We're going to write inverse. 1 over 2 times 3, 1 minus 4, 2. Right about this matrix now. Inverse in front of here. Right about this matrix now. 2, 1, 4, 1, 0. Right, so I need to multiply these two matrices here and do the factor. It's going to become half of again. And it's a 2 by 2 matrix. Right here. So, again, I'm multiplying the rows of the first matrix by the column of the second, and leaving the first value here, the first row, first column value. Multiplying this first row by the first again, first element and first element, element times element, first element and first element, element times element, times 2, 1, 4, times 2, 6, 1 times 4, 4. And this value here, position the first row second column. To get it, to multiply this first row by this second column. First element times first element, 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 first element times first element. one time in Q1, in Q1. This value down here position in the second row, first column. To get it, like this second row, like this first column. First element times the first element, second element times second element. First element in the row, first element in the column, second element in the row, first element times first element, second element times second element. 4 times 2 is negative 3, 2 times 4. The last value out here, position the second row and column. To get it, multiply this second row by this second column. Then first element times first element, element times element, first element times first element, element times element. Negative 4 times 1 times negative 1. Negative 4 times 1 is negative 4. 2 times negative 1. By this, it becomes half of the 10 to 0. And that is another divided each of these qualified to half of this in 5, half of this 1, half of 0, 0, half of this 2. That matrix R is equal to that. And that is equal to the answer. Then R for those values to make start for the specify the value. The R is 5. R is 5. S is 1. Is 1. G is 0. G is 0. G is 0. And that is that. That is a nice answer. Very good.
Yes, sir.
Remember, any question I got wrong, guys, maybe over send the video back after class. If question I got wrong, this over a little part wrong, this overcome scratch to the more part wrong. Clearly heard a lot of all the wrong. That hurt my hurt skin up and beginning in. Yes. Don't just go to the phone and hear me that just read it. I haven't been through more much. Alright, guys. So my Tuesday, Wednesday, Wednesday, New Year's Day, the holiday. And I was gonna class something. And I'm gonna let no one class. Here's I listen what do. There's an class. But I send working group, you know what it is. I give you a break. I'm class. And then I'm like send working group. Make sure that we keep working to get it. But people not doing the work, you have to do it. You want to come first. Not keep doing work. Alrighty. Okay, guys. That's it for today. Run a solid 2 hours. Let's not 2 hours. You all for more. Right. Just think that wrong. Ready to go. Alright, everybody. This is a thing now. Alright, everybody. See you. Bye.
Bye, sir.
Yes, sir.
Bye, sir.
Bye, sir.
Bye, sir. Alrighty.